Okay, next is example 6. A coil having an area of 8 cm square and 50 turns lie perpendicular to the magnetic field of 0.2 Tesla. If the magnetic flux density is steadily reduced to 0, taking 0.5 second, determine the initial magnetic flux linkage. Okay, so dia kata kat sini coil having area lies perpendicular to the magnetic field. Magnetic field B and the coil lies perpendicular like this. This is the coil. Okay, vector area A is like this. Okay, so the angle theta between vector A and B is 0 degree. Okay, the initial magnetic flux linkage is equal to N flux. So N is number of turns, flux is BA cos theta. Number of turns is 50 turns. B is 0.2, and then area is 8 times 10 to the power of negative 4 cos 0. And then we get the answer is 8 times 10 to the power of negative 3 Weber. Okay, so next is induced EMF. Okay, induced EMF we can calculate by using formula E. Induced EMF is equal to negative N KA cos theta. Apa yang changing? Magnetic flux density. So dB per dt. Okay, so negative NA cos theta B final minus B initial divided by dt. Alright, so substitute the value. Negative 50 for number of turns. Area is 8 times 10 to the power of negative 4 cos 0. And then B final is 0 minus B initial is 0.2 Tesla divided by time taken is 0.5 second. So the answer is 1.6 times 10 to the power of negative 2 volt. Dia positive EMF because the B, changing B adalah decreasing B. Jadi induced EMF akan positif. Okay, to oppose the decreasing of B. Okay. Example 7. A narrow coil of 10 turns and diameter of 4 cm is placed perpendicular to a uniform magnetic field of 1.2 Tesla. After 0.25 second, the diameter of the coil increased to 5.3 cm. Calculate the change in the area of the coil. So kat sini kita tahulah kalau dia cakap kat sini narrow coil placed perpendicular to the field, so sama juga. Maksudnya this is field and this is coil. So area between vector area is perpendicular to the surface and B. So angle dia berapa? Maximum lah. Theta for this case is 0. Okay, so dia suruh kita calculate dulu change in the area of the coil. So sekarang ni area initial dia 4. Area final dia, diameter initial dia 4 cm. Diameter final dia 5.3 cm. Okay, jadi you boleh substitute value. Change of area is equal to area final minus area initial. Okay, sebab dia bagi diameter pi d squared over 4 minus pi d squared over 4. You boleh simplify pi lah. Pi over 4. Okay, d squared 4 times 10 to the power of negative 2 power of 2 minus with ni kurungan besar lah, minus with diameter final kan, final letak yang final lah, ni R initial, D initial sorry. Okay, so ni D initial, D final, yang ni D initial, this one is D initial, ni adalah D final. So masuk yang final dulu lah. 5.3 times 10 to the power of negative 2 power of 2 minus 4 times 10 to the power of negative 2 power of 2, and then tutup kurungan. Okay, so the value is area yang kita dapat adalah 9.5 times 10 to the power of -4 meter square. Okay, this is change of area. Okay, next is calculate determine the induced current in the coil. Okay, if the coil has resistance of 2.4. Okay, jadi kawan nak cari induced current, you kena cari dulu induced EMF lah. Okay, so nak cari induced EMF dulu. Induced EMF is equal to negative N B cos theta dA per dt. Okay, so negative N is 10 turns, B is 1.2 Tesla, cos 0, and then change of area is 9.5 times 10 to the power of -4 divided by the time taken, duration is 0.25 second. Okay, alright, and then the answer for induced EMF is -4.56 times 10 to the power of -2 volt. Okay, ni baru induced EMF. So nak cari induced current, I induce sama dengan induced EMF divided by R. So induced EMF tadi 4.56 times 10 to the power of -2 divide by R. Ni tak payah masuk nilai lah sebab negatif tu hanya untuk induced current, induced EMF saja. Jadi untuk kira induced current, you just ignore the sign of induced EMF. So 1.9 times 10 to the power of -2 ampere.